Welcome to the quality of service subject. Actually, this is not a new subject to networking, but it's new to associate engineers since it was actually added only in the previous CCNA 201.25. Quality of service, or QoS, as Cisco names, other vendors do name it in another name, is actually meant for organizing or change or make maybe assign priority to your traffic so that you can make some type of traffics are more preferred than other types, which in result, just in case congestion happens. Actually, quality of service is only for the cases where congestion might happen or congestion will happen. What I mean by congestion is full bandwidth. And what I mean by full bandwidth is having maybe this interface. Let's make it a fast Ethernet interface. And fast Ethernet interfaces do have a speed or a bandwidth of 100 megabit per second. Congestion is when the real traffic that's passing through this interface, whether it was going forward or backward in full duplex environments, when it starts to cross 90 or 95% of the capacity, and since the capacity is 100 megabit per second, then let's assume that it started to cross 95% of the 95 megabit per second. So this is the start of the congestion. The real congestion occurs at when the real traffic reaches 100 megabit per second, or also it's the 100% of the capacity of the Ethernet or the cable or this media that's carrying the traffic. So when you reach this level, or the traffic reaches this level or this volume, at that time it's called congestion. So in this way. So what happens is that let's assume that it's a layer 3 traffic that's passing, and layer 3 traffic is packets. Okay, so maybe you are sending 100 packets, or let's make it 110 packets, causing the Ethernet maybe to have by force to carry around 110 megabit per second, and your capacity, this Ethernet capacity, is only 100 megabit per second. So there are 10 megabits per second, or for simplicity let's call it 10 packets, KTs. 10 packets will have to be dropped because you can't carry it right now, because at 1 second you send to me more than 100 megabit, and my capacity is only to transfer 100 megabit per second. So you are sending me more. So some packets must sacrifice themselves and they will be dropped. Okay, so just in case this router tried to inject 110% of the capacity, 10% of the capacity will be dropped at this interface before leaving. Okay, and this other side will not receive it because these 10% of packets, or maybe they are 10 packets, or how many they are, no problem, no matter, they were dropped. So just in case you were maybe suspecting that your network might face congestion or might be submitted by congestion or such thing in the future for any reason, because it will happen sometimes, or maybe most of the times congestion will occur. So you need to apply quality of service, and the reason to apply quality of service, just like I said in the beginning of this video, is to prefer some type of traffics upon another types. Just in case congestion happens, and it must happen, then okay, let's happen. So some type of traffics let it please pass first. They are VIP traffics, okay, they are important. Let them pass first, and all they take is around only 50 or 70% of the bandwidth. So they will, all of this VIP or all of this important traffic will go through smoothly without any drops, and the other packets no problem. Some of them, if it passed, okay, let it pass. The other, if drops, okay, let it sacrifice themselves. So you will arrange, or you will organize your traffic based on its priority and how important it is. Maybe you have your own traffic, your internal traffic, and at the same time a customer traffic. Both of them are running through the same interface. So customer do pays a lot of money for special service. You have something between you and the customer agreed on a contract, and it's called service level agreement, which is the SLA you will study in the CCNP exam. So to achieve the SLA, the customer must never see a congestion, or must never see any what's called, just say that we have packets dropping. Actually, we are losing packets, so it's called packet loss. Okay, so customer never wants to have packet loss. So I will prefer is traffic of the customer, and let my traffic drops, okay, and it will be transmitted maybe again. But mainly now we have two things. Since you got the idea of the congestion, I hope you did, and after that you should have get the idea of the quality of service is only the concept of preferring such type of traffic based on upon another. Or maybe you have like 4 types of traffic. I want this one to be very important, this other one to be important, this one to be medium, not really important, and the last one, maybe the fourth one, is very not important. So whatever happens to it, no problem. Or maybe I will make it in the fourth stage. But the most important is that the first one and the second type, the first type of traffic, or and the second type of traffic must never face packet loss, or must never be affected by congestion. Just in case congestion happens, it doesn't mean that you will always have congestion. Maybe you have it maybe like once a day, once a week, once a month. It's really normal. But just in case you suspect that your network might have, I'm sorry, congestion in the future at any time and for any reason or whatever happens, maybe you have this case. I just remember this one. Maybe you have the case of maybe like some switches. Let's say there are 3 switches. All of them are serving maybe a server or a router and getting the service this way, just in case something happened to, so the traffic is going half of it this way and the other half from this way. We are good, we have no troubles. But just in case this port or this port or this one or this one, or maybe this link or this link, or maybe this entire device, one of these 7 possibilities went down for a reason, then server doesn't care that a switch went down. It still wants the services. It still requires the services, or it's still giving the services to the end user or the client that is requesting from the server. So what it will do is that it will transmit all the traffic now on this other interface. So now you will face congestion, because maybe this one was 100 megabit per second, the other one was also 100 megabit per second, and the real traffic was maybe about 150 divided into 2, 75 and 75. When this one goes off for whatever reason, it had the 150 megabit per second will go from this way. So this is my capacity, this is what will happen. So a disaster of 50 megabit will have to be lost or dropped. So these are other cases that you might face congestion. Maybe it's not because just a new traffic happened, but just because someone was down, so now I have to take the responsibility of you and me, and this is too heavy for my shoulders. So congestion will happen, packet loss will also happen or occur. The moral of all the story is that quality of service is there. Thanks to all the scientists and developers who made it, quality of service will prefer some type of traffic upon another, just to avoid big troubles because there will be loss, but at least let's make it the less of the bad, okay, or the less of the evil. So if congestion will happen, some traffic be more preferred than another, yes, but just check two things. The first one is that generally UDP will be preferred over TCP. Why? Why would you prefer UDP upon TCP? TCP is also traffic. Why do you want to do it this way? Because TCP will automatically do retransmission. Do you remember three-way handshake that we talked about in chapter 1? TCP, when it sends when you want to send traffic or whatever type of traffic that's based on TCP in layer 4, before sending the traffic, the two links, the two ends, must submit three-way handshake between them, and just because there is congestion, three-way handshake will not be performed correctly, and since three-way handshake will not be performed correctly, then there will be no TCP transmission. Okay, so it will keep repeating itself. The TCP will keep repeating the three-way handshake until there is a sufficient bandwidth so it can send the traffic, and the three-way handshake will be completed first. After that, the traffic will be sent. So this is TCP. So TCP is connection oriented. It's reliable. All of those points were mentioned in chapter 1. But UDP is not. UDP is poor guy. It's fast protocol, but it doesn't have retransmission, it doesn't have three-way handshake, it's not reliable, all of those. So let's prefer UDP and give it a quality of service, assign it as quality of service, make it the very important traffic, which is the UDP traffic, just to make sure that no UDP traffic will be lost at all. And the TCP traffic, yes, it will not be lost really, but it will be delayed until the congestion finishes and until the three-way handshake is completed and the TCP retransmits the packets or the traffic again to the other end. So it's not really a loss if I applied quality of service on all the UDP traffic and left the TCP alone. UDP will all the UDP traffic will reach the other end, and for the TCP traffic it will be delayed, but in the end it will also reach the other end or the other person that's requiring it. Okay, so this is the first fact. The other fact is that who is UDP? I just mentioned also in chapter 1. When I talked about TCP, I talked about its connection oriented, it's reliable, it's the best, it's a bit slow, but all of those points and three-way handshake, etc. When I came to UDP and said, why would anyone use UDP? Or actually, what are the real applications in the real world that do use UDP until now, or was originally based or designed based upon UDP traffic? Voice and video. Okay, so you would prefer voice and video in your network to avoid losing them, to avoid using the voice and video traffic. So quality of service is there mainly for telecommunications company that you, or even networks or internet service provider companies that do provide voice and video data services. Okay, so you need to prefer voice and video upon all the other types of traffic, especially the other TCP types of traffic, not the other UDP types of traffic. I'm sorry, so that you will guarantee that the voice and video will not be lost and you give the best experience to the customer that's using voice and video data or voice and video calling. So this is the biggest point of making and using the quality of service. So all of those points until now have been discussed. So quality of service will prefer based on variety of factors. Some of those factors are classification, marking, queuing, shaping, and policing. All of those 5 terms you must know what are they, what's the real difference between them, at what point or at which point they do occur. So just before entering into those, you must know something very important, and that thing is, you know that maybe this is a router and this is another one. Let's make it simple, no difference in devices. Okay, just if I wanted to send traffic from router number 1 to router number 2, what's really carrying or sending the traffic here and what's really receiving the traffic on this side. What I do really have, if you used a microscope, logically, I'm joking, if we use the microscope to see inside, we should know or we should see logically that there are two ports inside: the transmission port TX and the receiving port RX. And also in here, the same thing, the transmission and also the receiving. So when I do send traffic, traffic will be sent from the transmission port of my device to the receiving port of the other device. And just in case this other device was also connected to a third device, there is here also some transmission and receiving. What would happen now? Something you must pay attention to. When device number 2 receives the traffic on its receiving port, it must to forward the traffic, just like we talked about forwarding behavior in chapter 3. To forward this traffic to device number 3, then it must be forwarded from the RX to the TX, which is the transmission port of router 2. After that, the device 2 or router 2 will transmit the traffic using this TX port from the TX to the RX. So check what's happening here is that each device, when it receives the traffic and wants to send it again, it has an RX and a TX. Of course, what I'm talking about, just in case you got confused, is that those two ports, this one has a TX, RX, this other one has also TX and RX. When I said that this device will send to the RX, after that it will be transmitted to the TX, I meant this TX. So after this or after that it will be, sorry, transmitted to here. So what I mean is that device number 2 will receive the traffic from device number 1 on the RX of this port and transmit it to the TX of this port, so that this one will transmit it to device number 3. So between this one and this one, between this receiving port of fast Ethernet maybe 1 to the transmission port of fast Ethernet maybe 2, there is a logical or virtual bridge between them. And the moral of all the story is that those 5 terms, some of them do happens on the receiving port, some of them do happen during this bridge while it's transmitting, and other of them will happen on the transmitting port of the other interface that will send the traffic to the other side or the other device. So until now we have talked about 3 major things: the congestion in network, the principle or the concept of quality of service, or actually the purpose of quality of service, why would I use it, and after that this simple architecture speech about that there is a TX and RX. I receive at the RX, bridge it to the TX of the other interface that will send it by itself or from its side to the other device that's requiring the traffic to forward it. Okay, so in the upcoming video, this should be enough for this video. In the upcoming video, I will start to talk about all those 5 terms and the difference between them. I hope the ideas that I have explained are clear until now. Just in case they were not, comment down in the video below in the video, please, and inform me whatever that's not clear, so I can do another video or explain it in the comments or support you, provide you with some extra resources. So thank you for watching, and I'll see you in the upcoming video. Goodbye.